I'm glad you guys can make it today. As Tom said, we're a movie streaming company. Netflix is the largest online movie service in the world with about 15 million subscribers in the USA and Canada. We just launched Canada about a month ago or something. Netflix was founded in 1997, and in the beginning it was all DVD by mail, essentially. You pay a flat fee every month, some $9 for the lowest end subscription, and we send you a DVD. As soon as you watched it, you send it back in a prepaid envelope, and we'll send you another one. You could also sign up for having more than one DVD at a time, etc. Became evident over the years that streaming video on TVs and computers is the future of video entertainment in your home. So Netflix has for years been active in streaming video, and that's largely what this presentation is about. And in the US, we have about 15 million subscribers at the beginning of this year. 18 million is the projected amount of subscribers at the end of this year in the US and Canada, which makes up about 5% of the total populace. And given the amount of people actually sharing subscriptions in, say, a family, it is a remarkable number. But as you will see from this graph, it's actually an accelerating growth curve, and we expect it to continue for quite a while. Netflix is available in all sorts of consumer electronics, like set-top boxes, PCs, gaming consoles, etc. And this means embracing a wide range of technologies and integration strategies. What we've found is that we want to do something we call dynamic UI, meaning that the UI is essentially pushed from the server rather than embedded in the firmware of the device. This gives us a number of advantages over having a solution that is in the firmware at all times. For example, we can change it easily, and oops, that was a little quick. And we can sorry about that, threw me off. I'll just go on. This graph illustrates the innovation in what we see the streaming of devices. We see the innovation curve to remain high for quite a while, though it will go slightly down. But we do see that the embedded part of it, meaning the actual firmware, the actual hardware, is probably going to decline, and the server-driven part of it will increase. That way, we need to shift the burden away from the OEMs and to the service providers. We want to be able to push a brand new UI that looks fresh and looks current. And that means shifting away from a traditional model of delivering the software to what we call the dynamic UI. Of the different parts of the stack, essentially, of our streaming solution, we find on the left side here that the core streaming technology, the DRM, the actual underlying important protocols, have become relatively stable by now. We also hope that UI frameworks, in the case of us, HTML itself, is going to stabilize and be relatively reliable for a long time, whereas the way we do things like account sign-up, content discovery, like finding the movie you actually want to watch, making sure that we recommend a good movie based on your past viewing history, etc., searching for a movie, and also things like parental controls, bookmarks, shortcuts. We see a clear shift that all of the things on the left side are mostly in the embedded space, in the firmware, whereas all of the things on the right side are mostly in the UI. This means that we can very easily change anything on the right side and have a device that is several years old still provide a brand new look and feel. Here's a little history of our streaming services. This one is taken from the Roku box of 2008, where it's all done in C++. It gives you a single list of the movies that you have selected on your web page, your Netflix account. In 2009, we extended it somewhat to using Flash to be able to have a little more dynamic content on the page, like we could give you some top lists of different genres, like thrillers, comedies, chick flicks, whatever. And this is the last iteration of UI, where we have also things like completely dynamic genres. We could detect, our backend can detect that you are really into, say, 80s horror movies. You want all Friday the 13th and Nightmare on Elm Street. And we can make a dynamic folder, essentially, for that. And there's a number of benefits to having this kind of information and being able to give it to the users, as we will touch more on in a moment. Essentially, in this space of A/B testing, we are able to test out a little change to our UI, or rather a large change to our UI, on only a subset of users. And given that we have millions of users, we can pick little groups and we can say, we're going to test run this UI with you, and we're going to notice the trends. Are you watching more movies or fewer movies? And then we can see, we can tweak it, we can try with another group. We could do that for big things like this. And you see the UI on the right was, for a while, something we tried. It didn't work out. And we ended up, after various iterations, on picking the left one instead. We've also done this for tiny little things, like should it be a more button or a plus button for the genre view? And any little tendency, given the amount of statistical data we have, we can essentially find the better UI through testing on little groups. Most of the time, these groups don't even know that they're, test runs. The first device we were actually able to do this kind of thing with was the PS3, and we tried all sorts of different personalized lists, and we noticed an increase of 40% in on-screen movie watching over the time when you only had a queue visible to you, meaning that if users are actually presented a choice to pick the movie during on their TV instead of on their computer, they're much more likely to actually see it. The convenience of having it there makes a huge difference in the amount of movies they watch. We've also noticed, as we've gotten more and more devices in the homes and doing dynamic lists like on the PS3, that people tend to actually watch the movie on their TV instead of the PC. It seems like not being able to choose the movie on your TV made people also not watch it on the TV. They would rather watch it on their laptops or on their desktop computers. But we see a huge shift there, with now 70% of movie watching actually happening on the TV. We ran through about 8 different types of the search interface before finding the one that seemed to be the most efficient, the one that people would come back to, that they would use for actually finding titles. And at this point, we seem to be used for about 10 to 20% of the titles watched. They use search. And this was a huge win for us, finding the search that ideally benefited users in finding titles. These kind of data keeps us very excited about our UI and our ability to keep customers happy about the experience they get from Netflix streaming services. In summary, the UI benefits of having a dynamic UI are, for subscribers, it gives them early access to new features. They get fresh content. They get something that looks current. We can continuously tweak it, make it the most efficient and easy to use for them. And they don't need to wait for firmware updates that may or may not ever happen. When someone's pushed the TV out the door, they're not usually interested in shipping a new firmware because they're not going to get any more money out of that. Whereas for the partners, it makes their products look fresh even long after they're released. And like I said, they don't need to do the firmware updates. And less resources spent on legacy products means more money earned per device for them. For us, it gives us a better enjoyment from our users, and we're able to keep our subscribers this way. Keeping them happy is the only thing that will make them come back. So we had essentially decided on having a dynamic UI for the application. That much was clear. But we had a couple of different choices in what we wanted to use to build this dynamic UI. There were DHTML and WebKit, Adobe Stagecraft, which is Adobe's Flash for embedded Linux, and other frameworks like Lua, Bluestreak, or we could build our own solution. Wouldn't necessarily be that hard either. Our favorite was WebKit, and there were a number of reasons for that. For one thing, HTML5 is huge. You have all the biggest companies seem to be doing it. The Googles and the Apples and Nokia, for that matter, are heavy into WebKit and HTML. We can easily hire for the UI engineers. The Silicon Valley is full of HTML expertise, and we had tons of experience in-house as well from building our own websites. It seems in general that the industry really has picked WebKit as something they want to use, especially in the embedded device space. In embedded Linux, WebKit seems to be absolutely everywhere. So we picked WebKit to use for our application, but we still had different choices on what we wanted to use, and we had some criteria for how we wanted to pick this. We needed to extend WebKit, because while HTTP live streaming would cover some of our needs for streaming video, there still aren't the hooks that you need to be able to do DRM, authentication, logging. There's a whole number of things that made it impossible for us to use as the actual video streaming. And while we're working with various standards committees and companies on this, it's not there yet. So we had to expose certain things to the JavaScript engine, like our video player APIs. You had to be able to make the script code call into this and say play movie, pause movie, stop. Also things like authorization, authentication, DRM, all these things, codecs, audio. This needed to be compiled into device in the firmware. And this needed to be exposed to the JavaScript. We needed to write a bridge, is what we figured out, and what we'd done in the past as well with things like Stagecraft 1.2. We had some other metrics we considered when we wanted to pick our WebKit port. The time to market, how long would it take us to get a solution out there, especially the browser extension part, because all the rest of it would essentially be, well, it wouldn't be my team doing it. We were responsible for delivering the browser and the extensions, and then the UI team would be able to write the UI in HTML. But how easily we could develop that web extension was key. Also, how accepting would our partners be of Qt, for example, or whatever technology we picked, is a huge factor. If someone comes in and say, I'm skeptical of this thing, it's going to be very hard to get it on the device. Also, we wanted real commercial support. In case we're sitting there, we can't figure something out, and we've checked all the forums. We wanted somewhere we could go to ask questions, and we wanted our partners to be able to do the same thing. Finally, we wanted to know that it was an active community, an active project, essentially, that was not dead, that stayed up to date, and where you could find the communities where you could ask questions, you could find the communities where you could hire people from, and you wanted to make sure it stayed current and didn't yet, suffer from bit rot. We considered a couple of different solutions. Considered the Origin web browser project, which is essentially a porting layer for WebKit, specifically targeting set-top boxes. We considered Chromium Skia from Google, and we considered Qt and QtWebKit. In the end, we picked QtWebKit for a variety of reasons. Go through the factors. We found that Qt had a lot of things to offer in the area of the JavaScript extension bridge. There's a number of little nooks and crannies in Qt's object model that make it simpler, and I'll go through that in more detail later. We also had some Qt experience on the team, and so we figured that time to market was a definite plus for Qt in this regard. Partner friction. It turns out that most of our partners are people that Nokia had already worked with, and they were very accepting of Qt. Oftentimes they had already tried to integrate it on their set-top boxes and on their various pieces of hardware. Another thing is that Qt natively supports DirectFB, which is pretty much a de facto standard in this industry. In the Blu-ray players, DTV, it's all Linux and all DirectFB. In terms of support, we got invaluable help from especially Noam Rosenthal and Tony Vitry in the Redwood City office. They were very supportive and able to help us with any little thing we needed to get it running. It so turned out that a common partner of ours and Nokia had actually already engaged Nokia to help them write a QtWebKit-based Netflix solution, which was, of course, a huge help in a lot of the initial hurdles were already conquered. And they've already in the Redwood City office completed a little prototype doing the UI in HTML and JavaScript. And so a lot of that meant that our technology was tested and tried. We knew it would work. This was a major factor in choosing Qt. Finally, we saw that Qt has a very vibrant developer community. The open source totally embraces Qt. There's tons and tons of developers, tons and tons of applications out there. And Nokia was very motivated to work with us on the parts of Qt that we felt weren't quite up to scratch, the things that needed improvements, like graphics performance. And there's been a number of talks at this show about graphics performance already. So we can see it's a very important thing for Nokia, making it perform as well as it possibly could. This is how the Netflix SDK breaks down, the way we see it. We have three parts. The Netflix SDK is all the stuff in the middle, including Qt, QtWebKit, the JavaScript bridge, and all the classes that the bridge talks to. All sorts of DRM, authentication, video player, state. And then in the bottom layer, we have what we refer to as the porting layer, which means the Qt port, making Qt actually run on the platform, doing any little changes, configuration that needs to make it run on these platforms. And the DPI, which is the device porting infrastructure, or interface even. All of these things are usually handled by the partner. And we consider this to make up the device firmware. This kind of thing remains pretty much stable for the life of the device. Then at the top, it's what we call the dynamic UI, which is just HTML and JavaScript pushed from Netflix servers, able to update at any given time. Every time you connect, you can get a new UI. The biggest challenge we had, or we considered to have, was making an inherently multi-threaded playback engine talk to an inherently single-threaded scripted environment. And we had some rather nasty experiences from integrating with Stagecraft 1.2, where there was essentially no model for writing plugins, no way to expose additional functionality to the Stagecraft scripting engine. What you have to do is make sure you get a license for the source code of of Stagecraft and build it into the actual product. Compile your extensions into the engine. This turned out to be an absolute nuisance, especially in terms of threading, that we had tons of hard-to-find crashes, hard to debug. And in the terms of Qt, we had the choice going either using Qt's QWebFrame add to JavaScript window object functionality, whereby you expose a Q object to the scripting engine, or we could use NP API, which is an old and tested technology. It's what is used for embedding Flash players or PDF readers in browsers. It is a way to embed a binary plugin, essentially, in your browser. We found, though, that Qt had all sorts of neat little tricks that made it easier to expose things to the scripting engine, like all Q object subclasses automatically gets their functions and properties exposed to the JavaScript engine. If you declare something as a signal, slot, or Q property, it can be accessed from the JavaScript. You can set and get values. You can connect to a signal. You can have more than one connection to the same signal. And you can call any slot. from JavaScript. It's also very good at converting types on each side of the function call. Like say a JavaScript array will turn into a QList of Q variants in C++. A JavaScript object will turn into a QMap. And Qt has a lot of neat little tricks for doing cross-thread communication as well. Essentially, signals and slots can be asynchronous, and arguments can be marshaled and delivered as a posted event at some later point. And all of this played a key part in making us decide to go the Qt road there instead of NP API. Bottom line, Qt really helped us accelerate the bridge. And after integrating in 4.6.2, we successfully integrated in record time. It took us a lot shorter than we actually thought it would. And we ended up with a situation where the top-tier platforms work very well. The mid-range are kind of okay. We still see some performance issues. And the low-end platforms we haven't actually really, or hadn't really tackled at the point. We had major concerns about speed, graphics rendering, and RAM and flash size of Qt. We compared Qt WebKit to other WebKit options, and we found that it's working well. We get good support from Nokia. It uses about the same amount of RAM as other things like Skia Chromium, but it is bigger. The library size of Qt, especially carrying around Qt GUI, Qt Core, Qt Network, is a lot more than you would carry around if you go the Google route for WebKit or others. So exploring those low-cost platforms a little more, we'll find that we had to optimize the solution because once we started doing CSS animations, I got a little ahead of myself actually. There are a number of factors that determines the quality of our Netflix application. There's the speed of the CPU, which is usually not very good on these devices. There's the capabilities of the graphics hardware, like how many pixels can it push through every second? How much memory? Does it have a FPU? Various factors. Then there's the layer of hardware drivers. It could have a really good GPU, but the DirectFB implementation can still be crap. You can get terrible bleeding speeds. It can fall back to software for all sorts of operations. Middleware is what, in this context, we consider to be Qt, which is, of course, plays a major part in determining the quality of the end result. The application framework here would be WebKit. And finally, the application itself, it's the HTML. And there are huge differences in how you use HTML in such a context for how it performs. Finally, you end up with various attributes like responsiveness, latency, attractiveness, how long did it take to do, how hard was it, developer tools, all sorts of things. And we found especially this area is absolutely key for people's enjoyment. People have a certain expectation from consumer electronics. They don't want to sit and wait whenever they've clicked something for it to actually happen on screen. They expect it to be relatively instant, and they expect it to look good. So we started using CSS animations for giving it sort of the 21st century look and feel. And we would say do an animation around something along the lines of this, where you see this menu here. It's going to fade into the background, and the boxes on the right are going to enlarge a little bit and go into the foreground. And we'll also display a little focus rectangle. So we did that, easy enough to do in HTML with later CSS extensions, or not extensions, but with CSS animations. But we got about 1 frame per second. And we also had another type of animations where you have this screen and you want to scroll up or down. You want to move the focus down to the row below, and you want the whole row to shift upwards. And similarly, we got about 1 frame per second. This is, of course, not acceptable, and I'll show you a little video of it to illustrate how ridiculous it looks. And this is just not very usable. You can see you would rather have this UI without the animation. You will just sit there and get angry at it's taking too long to do everything. And this is a mid-range device. It is certainly not the cheapest one we had out there. So we had major concerns. How are we going to address this? There seems to be something wrong, and what we originally thought was that DirectFB must be to blame for this, that their implementation was inferior, or just as likely that the graphics hardware just couldn't handle this kind of load. So we started digging into it, and what we actually figured out was that CSS animations are rather heavy on the CPU side of things. Every frame of CSS animations force WebKit to do re-layout and re-render of absolutely everything. And also we found that all sorts of blits and fills would fall back to software due to some little intrinsics of HTML, and it would end up not taking advantage of the GPU not nearly as much as it could. So we started looking into this along with Noam Rosenthal from Nokia, and realized that there is this extension inside WebKit called accelerated compositing that is by default not enabled. It was until very recently only supported by the Safari browser. They use a Mac-specific implementation that relies on core animation to do it. Google Chrome has very recently implemented something using OpenGL. And Qt, as of 4.7, has a Qt graphics view-based implementation. Now, so the way it works is that by certain hints to the compositor, it figures out that an element of HTML can be considered to be a layer. For example, if you tell it to have a z-axis of 0, also if you give it an absolute position, it will know that this is a layer. And this adds up to it being able to be reduced to just an image that gets moved around and drawn with different parameters, like, say, a different transformation, different opacity, various different ways you could draw it, and you wouldn't have to relay it out. You wouldn't have to draw text again. You could just move the image around. But this didn't come for free, and we had to write something. So between Nokia and Netflix, the Texturemapper was started. Part of the reason for this was that the solution that was ready for Qt 4.7 we wouldn't be able to use it because it relies on graphics view, which we don't use. If you use we consider it way too much overhead to use a graphics view when we would only have one item in the scene, a single QWeb graphics view or whatever it's called. So we started writing a new abstraction called the Texturemapper to be able to do this outside of graphics view, still using Qt. And after getting it to work, and actually another thing I should mention about that is that it was largely motivated also by Nokia's desire to go straight to OpenGL in this layer. They don't want to go through QPainter for these animations. They want to go straight to OpenGL and do GL commands on the various textures then, hence the name Texturemapper. So here's some statistics of the frame rates we were getting before in 4.6.2. Once we had the Textmap solution in place, we got way, way better frame rates. And really anything above 60 is sort of superfluous in that regard. You don't really need more than 60. So you get essentially, at least on our higher end hardware, every bit as much as you want using the Textmap solution. And here's a little video, the exact same hardware as before, just recompiled and with a different switch. And you will see this may not get all the way up to 60 frames per second. It's probably more in the realm of 30, 35, but still a lot more acceptable than the initial video. And you can see the animations sort of contribute to the experience here. They're not in the way of it. So the status after integrating with Qt 4.7 is that and by the way, we are looking to push this to WebKit trunk, and it's also something that will be possible to be taken advantage of by other ports. It doesn't have to be Qt for this. It's a very generic in nature. So if you want to check it out now, it's on Gitorius, on Noam's repository there, but we are in the process of getting it pushed to WebKit trunk, and hopefully it will be there in not too long. So we find now that the top-tier platforms still work very well. We now see that the mid-range actually also work well. And in the low-end platforms, we find that they can render things fast enough, but we still have an issue with RAM and flash footprint. The challenges we see when we get a new box that we want to integrate things on is that we want to make sure the DirectFB implementation is capable and of taking advantage of the GPU. We want to make sure the GPU is good enough to do the rendering. And we want to make sure there's sufficient video memory for actually accelerating commands, because oftentimes you have a very limited amount. If you have too many off-screen buffers, too high resolution, it will fall back to software. So these are things we always find that we have to test out when we get a new board. Minimizing RAM and flash footprint is it's a big deal to the people, to our partners, because they're very low. They don't make a whole lot of money per box they ship. The key for them is to squeeze every penny out of the cost, and any couple of megabytes less of anything means a higher rate of returns for them. So it's minimizing the size of the solution is important in that regard, but also in the application startup domain, it's important. We had boards where I think it took, say, it could load about 5 megabytes a second of library code. So you would add an additional, say, maybe 6-7 seconds just to loading Qt and the application. And that is, never mind it actually running any code, that is just loading it into memory. So we see that the size of Qt is a problem in the lower end devices. We would also like to be able to make Qt and QtWebKit especially available to other applications on the device, in a sense to make us seem like less of a hog of resources for the partner. If they were also able to offer a solution that lets people, say, browse Flickr or Facebook or something like that, it would make us seem like less of a cost to have on the device. The way we see it, the path forward for Qt and QtWebKit is they're definitely emerging as the standard for DHTML. The other rendering engines seem nowhere near as capable in the embedded space. And in terms of HTML5 compliance, WebKit is way up there. All sorts of acid tests score 100 with the Qt-based WebKit browsers. So it's looking good in that regard. Qt continues to be a trusted name, something that our partners like us to use, and they're very comfortable putting on their device. There's a certain amount of unpredictability in the WebKit integrations. Like, people branch off at a certain point, and then suddenly you might be missing, say, a security fix that is in a later release of WebKit. Qt is very good about this in that the code actually lives on webkit.org, but they will pull in occasionally the latest version and make sure you stay current with your Qt release. So that's another thing that Qt definitely helps us out with, is making sure we stay current. We still do need to make the SDK available, and our security model, we need to expose that to the WebKit extensions. So how is Qt helping us reduce the size of the flash and RAM? And I actually heard in other presentations and from talking to the trolls that there will be more Qt modularization. It should be possible to bring down the size, and I've gotten some input while I've been here that we will definitely take back to the team to try and make it smaller. Because in the grand scheme of things, there's only a very small subset of Qt GUI that we actually use. Everything we could throw out of that would be a great win for us. That was actually all I had, and I think I raced through that in very quickly. Are there any questions? Go ahead.
So, I'm a user of Netflix, and I should tell you that amazing job that you are. So, question. So, with PS3 you ship a DVD, with PS3 you ship a DVD, and what does that DVD contain? Like, is it having a Qt library is very specific to the PS3 hardware and the application core?
The situation on the PS3 is actually that the application you're using is not actually using Qt. It is a pure C++ solution. It's on a DVD strictly for licensing purposes. We signed an exclusive deal with Microsoft, meaning that we could not install on the firmware of gaming consoles, but that deal will expire very shortly, I think in a week or so. And that will be, then you will be able to install it on the firmware, and you will get a Qt-based solution. Now, sadly, we are not able to share that Qt-based solution, or we're not able to share the port. Anything we would do actually in Qt, in the LGPL side, of course, we would have to share, but that's not where the real port is done. And it all relies on private APIs from Sony that you have to talk to Sony to get. So we are not able to share it, and I don't think other people will be able to use it on the PS3. Now, I'm just an engineer, so there might be other people able to answer that better. But
and the same thing with iPhone. So you also have a nice app for iPhone. So again, that is Qt-based?
No, to the best of my knowledge, that one is not Qt-based. That one is using Apple WebKit, I believe. I am almost certain. I can look into that, and I can send you an email later. But
So do you have any solution of Netflix application today running on ARM-based platform?
I think so. The vast majority of them seem to be MIPS, but let me see. Yeah, I am pretty... Oh, I do believe we have that. Do you have specific concerns about Qt on ARM? Because, I mean, Nokia runs Qt on ARM pretty much on all their phones, right? So what specific concerns do you have? I have certainly run Qt on ARM at various times.
So when you're running it on ARM, is DirectFB a requirement, or you use Qt embedded, or what is the backend you are expecting?
It tends to be, in my experience, on ARM, there tends to be OpenGL. And often X11, whereas in the MIP space, it's more we're using QWS and DirectFB. But Netflix in no way requires DirectFB. That's essentially in the Qt layer only. So yeah.
And all the encoding and all the decoding of the video stream and audio stream, it is done on the CPU, or you require a DSP or video accelerators for that? That would depend on the capabilities of the CPU, but I would have to assume, and this is a little bit outside of the code that I actually work with. This is sort of what the partners do, but I would assume that it's always done by DSPs, and because they tend to be cheap units that probably couldn't get away with doing that on the CPU. But we're not using Qt for the video per se. It's all handled in an outside layer. So yeah, the WebKit QWebView is not displaying any video in our solution. What actually happens is that at certain times when you see overlays over the video, we make the QWebView transparent and only paint in certain parts by having QtWA, no system background or something like that. So basically, the video stream is taken and displayed on the video plane, and the GUI is displayed on the frame buffer or the OSD plane, and it is made transparent whenever the video is being played.
Yeah, and by far most of the time there's only video there as well.
Yes,
right, so
but whenever any user presses a button, the transparency is reduced to opaque, and it simply pops up.
Yeah.
Got it. Great, thanks.
No problem.
I think we've run out of time, Anders.
Oh.
So, thank you very much.
Thank you for coming.